Okay, so for scale 3 we have to choose 3 angles, so for my angles, angle 1 will be pi over 6, and the reference for that is 5 pi over 6. And for angle 2, I'm going to put pi over 4. My reference will be, let's get 5 pi over 4. And for my third angle, let's say pi over 3. Reference would be 5 pi over 3. And then we're also supposed to choose a quadrilateral angle. And from that, mine will be pi. Okay, so for part A, I chose the angle 150 degrees, or 5 pi over 6. And then, so what we're supposed to do is, so we have the graph here, and we can say that if you draw a circle out, so the corresponding point for this thing would be over here. So we could draw a line down and then a line like this to create a triangle, which we can write out over here. And we know that the distance from 0 to the point over here would be negative root 3 over 2. And we're finding this from the unit circle, and the height would be 1 over 2. And the radius is always 1. And we know that this angle here is 90 because we just created it. And based on the reference angle of 5 pi over 6, we can figure out that this angle is 30 because the angle we chose is 30. And then, so if that's there, we can use 180 minus 30 minus 90 to get 60 here, which is a 30, 60, 90 triangle. And then we can use you gotta find the sine, is what it's asking for in part A. So sine is opposite over hypotenuse. So for opposite of hypotenuse here, so for 30 degrees, opposite was 1 over 2. Over hypotenuse is 1, so that's just 1 over 2. And then for cosine is just adjacent over hypotenuse. So that one equals, for 30 degrees, we get negative 3 root 3 over 2 over 1. And so that one's just negative root 3 over 2. Okay, so for part 2, my angle is 5 pi over 4. And then we can draw a circle out again. So the point for this one would be somewhere down here. We can draw the same vertical line and the same line from the origin to determine what we need right now. And then if you draw the triangle off to the side again, we would draw something like this. So once again, we know that angle is a 90-degree angle. And then, so we know from the unit circle that this distance is negative root pi over 2. This one's also negative root 2 over 2. And so since these two sides are the same, and 90 is one of the angles, we only have 90 degrees left to work with in this triangle. So both of these angles would be 45 degrees. Obviously this is not drawn to scale. So both of these would be 45 degrees, creating a 45, 45, 90 triangle. And then from the corresponding point, we got to use, it's asking for sine and tan for this problem. So sine is opposite over hypotenuse, and opposite of the 45-degree angle would be negative root 2 over 2 all over 1, because it's hypotenuse, and that would just be negative root 2. And for tan is opposite over adjacent, which is just root 2 over 2 negative root 2 over 2 over negative root 2 over 2 again, so it's just 1. Okay, so for part C, this is asking for the cosine and the cosecant. So we can draw out the circle again. my angle for this one was 6 pi over 3. So we have this whole circle right here. The corresponding point for this one, 6 pi over 3, is down here. We can draw this again. Once we get that, we will get a triangle like this. Where this one is 90 again. This angle over here will be 60. This one will be 30. And then using the unit circle, we can get that this is negative root 3 over 2, and this one is 1 over 2. So for the angles, we got to find cosine, which is just adjacent over hypotenuse. And so cosine of, the cosine of 5 pi over 3 would be adjacent over hypotenuse. So for that, it will be 1 over 2 over 1, because the hypotenuse is still 1. It's just 1 over 2. And for the cosecant, we would have to do 1 over negative root 3 over 2. And this is because cosecant is basically just 1 over cosine. So, so cosecant is basically just, you have to flip, the cosecant is just 1 over sine. So that's basically we're flipping it. So we get 1 over sine so sine is normally, would be hypotenuse over opposite, but normally since sine is opposite over hypotenuse, we would flip it to get the h over o. So for this problem we would get, so that's how we got this number. And then so if we simplify that, we can get 2 root 3 over 3 after doing the whole, so first we would have to do 1 times 2 root 3 after we flip and multiply, which would be 2 root 2 over root 3, and multiply by root 3 over root 3. Then we would get that. Now for the final part of this, we have to find the secant and the cotangent. So the quadrilateral angle would be 180. And so secant is 1 over cosine. So since our angle is pi, we would have to find the cosine of pi, which is just negative 1. And so 1 over negative 1 equals 1. So that's what the cosine of, or that's what the secant, this is negative 1, so that's what the secant of pi would be. And then next we would have to find the cotangent. And so if we do this with this, we know that cotangent equals nothing but 1 over tan. And since tan is opposite over adjacent, 1 over tan would be adjacent over opposite. Or we could just do it like this. So tan of pi equals 0. Then we just automatically know that 1 over 0 is undefined. And then so the cotangent of pi would be undefined. To further prove this, we could graph it also. So for 1 over tan, the graph looks something like this. And then each of these asymptotes are created at an increment of pi. So this one here would be 2 pi. So, and this one's pi, negative pi. So it would not work at all. So we also see that this one goes up and this one goes down. So the limit does not exist because it goes to infinity and negative infinity. So that's it for this problem.